Membrane proteins. Membrane proteins are responsible for the most dynamic processes carried out by membranes. Most membrane proteins can be classified as being either peripheral or integral. Many of the proteins associated with membrane can be released from the membrane by relatively gentle extraction procedures such as exposure to solutions of very high or low ionic strength or of extreme pH. These procedures interfere with weak covalent non-covalent interactions between protein-protein or protein membrane lipid but leave the lipid bilayer intact. These proteins are referred to as peripheral proteins or extrinsic proteins. These proteins are bound to membranes primarily by electrostatic and hydrogen bond interaction and do not interact with the hydrophobic core of the phospholipid bilayer. They are usually bound to the membrane indirectly by interactions with integral membrane proteins or directly by interactions with lipid polar head groups. Most peripheral proteins are soluble in aqueous solution. Spectrin and ankyrin are very common examples of peripheral proteins present in the membranes of RBCs. Spectrin and ankyrin membrane proteins help determine the shape of flexibility of the RBC. Proteins that are held in the lipid bilayer very tightly and cannot be released by relatively gentle extraction procedures are called integral proteins or intrinsic proteins. Integral membrane proteins are mostly transmembrane proteins which have one or more segments that are embedded in the phospholipid bilayer. Transmembrane proteins contain non-polar amino acid residues with hydrophobic side chains that interact with fatty acyl groups of membrane phospholipids, thus anchoring the protein to the membrane. All transmembrane proteins are amphipathic. Transmembrane proteins may be single-pass monotopic or multi-pass polytopic. Glycophorin is a major single-pass transmembrane protein of RBC. It is a small glycoprotein of 131 amino acid residues. It was the first membrane protein for which the complete amino acid sequence was determined. Despite their abundance in the plasma membrane of RBC, their function remains unknown. Membrane proteins, which are covalently bound to lipid molecules, are called lipid-linked or lipid-anchored membrane proteins. They form covalent attachments with three classes of lipids: isoprenoid groups such as farnesyl and geranyl residues, fatty acyl groups such as myristoyl and palmitoyl residues, and glycosylated phospholipids such as glycosyl phosphatidyl inositol GPI. An isoprenoid group that contain 15, that is farnesyl, or 20 geranyl carbon atoms attaches to a cysteine residue at the C terminus via a thioether linkage. A myristic acid, which has 14 carbon saturated fatty acid molecule, attaches to a protein through an amide linkage to a alpha amino group of an N-terminal glycine residue. A palmitic acid, which is a 16 carbon saturated fatty acid molecule, attaches to a cysteine residue close to N or C terminus via a thioester linkage. A glycosyl phosphatidyl inositol molecule, which is GPI, attaches to the C terminal amino acid via an amide linkage. GPI linked proteins occur on the exoplasmic phase of the plasma membrane.